Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's 9 in class again today. How have you been? We are going to continue with our land use land cover video. On today's video, we are going to show you how you can calculate the area of each of these raster values, right? Good. Now on our previous video, we did a bit of classification and then we have our map somewhere around there, right? Good. And we knew that this blue represents water, green vegetation, this orange or yellow crop, then the red built up area, and the rest of that. You can refer to that video so that you can see the description of each of these other words, each of these other legends or keys, right? Now what we are going to do now is that we are going to determine or calculate the areas, the area of each of these what values, and then we are going to have our data, or let's say our values, or let's say the area rather, on an Excel spreadsheet, right? So if you're coming to the channel for the first time, you can encourage us by subscribing, and if you're a returning viewer, thanks for always checking up on us. So let's come to the processing toolbox. Then we search for raster unique. Okay, good. Raster layer unique values, right? Good. Now raster layer unique values. So you double click on that. Good. So when you have the raster layer, let's get back to our layers. When you have the raster layer unique values up, your input layer will now be what? The imagery that you've classified, which is our clip underscore obk, because that's obiako, right? Good. Then we have what the band number there. So we can leave the other settings as default, and then we click on run. Good. Before we leave, this algorithm returns the count and area of each unique value given in a raster layer, right? Good. Each unique value, that's each of these unique values given in this what raster layer, right? It returns and count. It returns the count rather and area. It returns the count and area, right? Good. So what we are interested in is what is the area. So we can see that the algorithm has been completely run. Yeah, finished. So we can close this. Now you can see what the result, that's the unique values report. It's saved on this file part, so we just would click on it, right? Good. Now we have our report somewhere around there, so you can see the projection. Now there is something very important to note. If your data, that's the raster data, is not in projected coordinate reference system, the area you are going to have will not be in square meters, right? You can see what the different values, the pixel count, and then the area, which is what we are interested in. So if yours, maybe if you're working on a projection that stopped at WGS 84 or any other geographic CRS, you need to follow through to the end to see how you can convert what your area to what to maybe square meters, because you don't want it in degrees squared, right? Good. You need it in meters squared, right? Good. So since we have been able to see our report, we can easily copy the all of this that contains the values, the pixel count, and the area. Just Control C, right? Good. Upon copying it, you just go to Excel. Good. So we are now on Excel. So we just try to paste the data we've copied, right? Good. So you go to any of the cells there, then you paste special, right? So we are pasting a text. Let's click on OK. Good. So we have what our data, or let's say the information that we copied on our from the report pasted here. Now there are important things to note here. You know, the values, as we said earlier, they have description, so you can just create a new column for the description of each of these values, right? Good. Or you can decide to replace it with what? Let's just leave it at ds, right? Good. Or you can decide to replace it with these values. Instead of having the value numbers, you can have description. So let's say this represents, let's say, water, for instance. We are not saying what one represents water. Let's say number 2 represents vegetation, or so. Number 3 represents built up area, and the rest of that. So depending on the description that each of these values have, you have it there, right? Then the next thing is what the area. So if you want to know the percentage covered, let's say the percentage of the first value. Now let's try to be sure. Please pay attention. We are not saying these values represent this description, but we are just using that. We are only using it as illustration, right? Good. So for the right values, or let's say for the right description of these values, refer to the legend that we've shown you on the previous video. So let's say we want to know the percentage of water, vegetation, built up area. Okay, let's use this as built up area because relatively the built up area is always the largest, right? Good. So let's just delete that. So we are just saying, oh, we are trying to use this as what, as an illustration. So the first thing you need is to what, is to get the total. So you say equal to, then you now sum the different sum the areas, right? Good. So you just drag down, you click on enter. So this is the total area covered, right, by our raster data. Then the next thing is what we need, what's the percentage area. So let's just create another column somewhere around there and we call it percentage area. Now the percentage area is simply what, each of the area, let's try to put this in a bracket for us to have it easily together. Each of these area divided by the total area, right? Good. So let's close this bracket. Multiplied by 100. Multiplied by 100, right? Good. So it gives us what, the percentage covered by what, each of these area, right? Good. Now, if we want to autofill it, it will still come down. Let's just try it for the first point. You will see now that the next value is taking us down, which is not what we need. So we need to what, lock this particular cell. Sorry. Good. For us to lock it, we need to come down to our formula and then introduce the dollar sign so that that cell will be locked, right? No, that's not dollar sign. It's a dollar sign, so that that cell will be locked. So let's do that. Enter and see. So we can now easily autofill, right? Good. Now we have autofill. So for you to check if the percentages you have is correct or if they are correct, your sum or the sum of all of these percentages should be equal to 100. So now let's try that and see. Okay, so we just drag down all of these and then hit enter. So we can see that the values we have is correct, right? So the values we have are correct. So this means that the highest of 73.45, or let's say, yeah, of 47 represents built up area. Then I think the lowest of 0.1, we don't know the value actually. So when you go through the description from the legend, you will understand what we are trying to explain. Also, we told you that let's say your projection is in geographic, right? Good. And then you're trying to maybe get the area. So the first thing we are going to do now is that let's assume that the values you have on that area is not in square meters, but it's in degrees squared. So what you are going to do is you take this pixel count. Are we together? So let's assume, remember that this particular part of the video is trying to describe when your, let's go back to the report. We are trying to assume that what, your projection is not in projected but geographic, right? Which means your values here will not be in area, the area here that will not be in meter squared, it will be in degree squared, right? Good. So that's the emphasis we are trying to make now. So what we are now going to do is that for your area, it will be something like this. Then you say this pixel count will now be equal to this pixel count multiplied by the resolution of what, your image. So I think this is actually what, a 20 meter by 20 meter resolution, right? Good. So you just click on enter. So it now gives you what, the area. Remember that this is when the report gives you, or let's say the report states that, or you know that the raster data you imputed as what, a, a projection that is geographic and not projected. That means the geographic, the units is in what, decimal, or let's say, yeah, degrees, right? Good. It's in degrees, whereas in projected units in what, it's meters, right? Good. So trying to change it from that degrees to meters. So that's when you now have the equivalent in meters. Please pay attention so you don't mix all of this together. The first part of the video describes when your raster data is in projected. This latter part is trying to explain when your raster data is not projected with geographic, and then you're trying to convert what, your area to square meter. So you now multiply your pixel count by the resolution of what, your imagery. Then you now have the area what, in square meters, right? Good. So when the area is out, you can decide to go about getting the percentage area, to know how much, or let's say the percentage of each of these values of what that is covered by what, your image, right? Good. So we hope we've provided solution to this particular solving problem. We are going to see you on our subsequent video. Ensure you go through the previous video so that you can understand the build up to this part, so you don't get any part missing or broken, right? Good. So until we see you, keep being good at what you're doing and have a very good time. Bye.